Hello everyone. I'm very sorry for I delayed about like uh, three 3 days to update the new video. Which is partially because I was preparing the University application of Hong Kong, and yeah, and I was in I was like a little bit fever recently, and yeah. So then today I will restart my video from this fifth video, and uh, yeah, and as you see on the whiteboard, I've picked these three problems. Uh, yeah, and so firstly, it's a warm up. Uh, yeah, so let's start it. Uh, so it's like so firstly, I want to prove that n to the power of 5 minus 5 to the power of 7 cubed plus 4n is 0 by 120. And yeah, so by observing the right-hand side, we can factorize it, which is n to the power of 4 minus 5n squared plus 4, right? And we can factorize 2 to n squared, which is n times n squared minus 4 times n squared minus 1, right? Okay. And so this shows that this equals to uh, n plus 2, n minus 2, n plus 1, n minus 1. So it's like a 5 consecutive integer of n. Yes, yeah. And and is yeah. So I think like because 100 is equals to 5 factorial, and so and so this is like uh yeah. And what about like yeah, it's quite obvious. It's quite obvious. Like uh there must exist like factors of 5 factorial. But if I want to carefully say it, so first the n equals to 1. This is absolutely correct, right? And if I want to say it for further, uh, I'd like to uh like use like this is n plus 2 factorial over uh like n minus 2 n plus 2 factorial n minus 3 factorial times 5 factorial. This is equals to like I think it's n plus 2 to 5, right? And because as we all know, uh, that this is the combinatoric number is a integer. So which means we can observe that this is an integer. So this is an integer when divided by 120. So it's an integer. Yeah, this is a better explanation. Second question is about uh series of signs. Uh, and with the provision of this formula, in our China, this called 格差化机 and yeah, yeah, and uh, so it's like 激化合差、合差化积. These two formulas are very very popular in Chinese high senior high school, but it's a little bit messy. So in this I may try to insert some rhythm that I used to remember this formula. So but it's some points like I speak in Chinese. So it's a little bit hard for you to understand, but it's fun I think. Yeah. First I'm try to insert how I remember this kind of equation. So the first is 和差化积化成积 so it's nonsense. It just tells about this uh tells about this formula. What it's saying. And the second is 余弦加减函数 e. Yeah. So it's something like if there's cosine, so like cosine alpha plus cosine beta. 余弦 this means cosine. 加减 means plus or minus. 函数 e, it's a little bit hard to explain to you, which means it's if direct translated, it's different functions. Sorry. Oh, yeah. 正弦加 yeah. So in Chinese, this is called 正弦 sine 加减 plus or minus. This is means different different functions. And now let me show you how this works. Okay. So 正弦加减函数 e, which means like if it's sine alpha plus sine beta, it will remain like two. Actually, this is two functions in form like sine or cosine alpha plus beta over 2, right? And sine or cosine alpha minus beta over 2. So so this is what different function means. Different function means this function is A, this function is B. A and B are different. So like this one, sine and cosine. And if yeah. So like the main function, like A and B are different. Yeah. And the third is 减法运算作用证 which means like this is 减法运算。减法运算 is in Chinese it's just the minus sign here, and this means 作用证 is like 正 refers to 正弦, so it's something like if there is a minus if there is the minus sign occurs in the left hand side, this B must be using sine. So it's something like if sine alpha minus sine beta, according to these two lines, I've known that this is sine minus this is sine minus or plus, right? So this equals to firstly A and B are different functions, and because we know that this is minus sign here, so which means that yes, I need to use the sign on this. So actually I can write it in like sine alpha minus beta over 2 and cosine alpha plus beta over 2. Yeah. And okay. So actually why I think this this point is very useful, because like it tells four formula in just 3 lines, right? So because this means like if it's manipulation, if it's yeah. this means that if it's the manipulation of the uh like the sign, right? And this implies that if there's a manipulation of cosine, they add together or they minus with each other, the functions of a and b equals to are the same. Right? So it indicates or like it implies that a cosine, yeah, and this implies that if it's plus, if there's a plus sign in the left hand side, the right hand side, the this one be using cosine. Yes. So actually, this this line indicates a lot of this line contains a lot of things, a lot of things. Yeah. And uh and the first line is 余弦相减，不正正。Yeah. So it's something like if it's cosine alpha minus cosine beta, uh the answer is negative sine sine. Yeah. And that's the total formula. Yeah. That's a joke. Never mind. Okay. So now we're considering this equation. Yeah. Sine alpha plus sine beta equals to 1 over 2, 2 times this. Yeah. Yeah. So what can we say about this one? So firstly, uh, yeah. So actually, if I want to apply this one into the previous one, uh, if I want to apply this the right hand side one into the previous one, which means I may uh uh so, so like sine one plus sine two is equals to two sine doing favor, cosine over two, something like this. And uh yeah, so this something like that. But how to use this in the next one. Sorry, sine alpha plus sine. What about like if I consider sine 1 plus sine 3 is equals to 2 sine 2 times cosine 1 here. And sine 2 plus sine 4 equals to 2 sine 3 uh, cosine 1. Maybe. Yeah. So actually, uh, 2 sine 2 cosine 1. Uh, so it's something like sine n minus 2 plus sine n equals to 2 sine n minus 1 cosine 1, because I may try to use this in invariant part cosine 1. So if I use the cosine 1 here, which means I can obtain that uh, sine 1 plus sine 3 plus sine 2 plus sine 4 plus sine 3 plus sine 5, which means like uh, uh, this is if they add to, so it's like sine 1 plus sine 2 plus sine minus 1 plus sine n. This is not multiplied by 2. So like it's like this is s, this is 2s minus this. 2s minus this equals to uh yeah, this equals to 2 cosine 1 s minus uh uh sine 1 minus sine n. Right. So actually, what about like finding s here? So minus this equals to uh here, but it's this sine 1 plus plus sine 3 sine 2 plus sine 4. So so the solution of this formula how to solve the problem. I'm wondering, what about it? Yeah, first sine 1 plus sine 6. This is the first approach, but it's like 2s here and 2s there. So this is cancelled out, okay? And is this one? sine 1 plus sine 2 equals, yeah, so what about like sine 1 plus sine 2 equals to 2, sine this, cosine this, and it's like a sine 1 plus sine 2 plus sine 3, this equals to, um, 2 sine 2 cosine 1 plus sine 2. Yeah, but it's, what about like considering, yeah, and what about like using other formula? So if like if sine n equals to, uh, what about like considering cosine alpha minus cosine beta equals to, yeah. What about like considering this formula? So it's something like and I use sine 1, sine 2, uh, so it's sine 1 equals to like cosine, wait a minute, yeah. It's so how to express sine 1 here. So uh firstly, I will try to substitute sine 1 into this, or substitute sine 1 into this, right? Uh, so which one is better? I think like the sum is better. Yeah. So what about like considering like sine 1, this equals to sine uh 0 plus 2 over 2, right? So this is like, yeah. So sine 2, we can express it into sine uh 2 plus 4 over 2. Yeah, it's something like this. This is better. This is better. So uh, uh, what a trick. Yeah. So the previous formula I give to my problem is wrong. Yeah, because I haven't seen it before, and I just recognize that the problem asked me to use uh uh the formula of like to sum the sum of the sum and the difference of the trigonometry, and then I was just thought of using that, but actually it's not, yes, it's not something like that, right? Because I want to use the telescope, something like telescope here. uh yeah, because if I can express this one, I can express that sine 1 equals to uh yes, so cosine alpha minus cosine beta equals to negative 2 sine uh uh beta sine alpha minus beta over 2. Yeah, something like that. And so firstly, sine 1 equals to uh what about sine 1? Sine 1 equals to sine 0 plus 2 over 2, right? And so what about like, and sine 2 equals to uh sine 2 equals to sine 2 plus 4, sorry, 0 plus 2. So it's 1 plus 3 over 2. 1 plus 3 over 2. And sine 3 equals to uh, sine uh, 2 plus 4 over 2. So firstly, I can express it in cosine 0 minus cosine 2 equals to of this 0 minus 2. 0 minus 2 is 0 minus 2 is something 0 minus 2 is something like uh, a negative, and because sine is the ultimate function, so I can express it into 2 sine 1 yeah sine 0 plus 2 over 2, yeah, something like that. So this equals to 1 over 2 sine 1 cosine 0 minus cosine 2, and this equals to uh yeah, this equals to uh what more like cosine 1 minus cosine 3 equals to 1 minus 3. Yeah, I still using, so it's like 2 sine 1, 2 sine 1 sine 1 plus 3 over 2, right? So I put it here. Yeah, so actually this terms become like 2 1 over 2 sine 1 uh 1 over 2 sine 1 uh cosine 0 minus cosine 2 cosine 0 minus cosine 2 uh plus sine 1 minus cosine 3, right, yeah, and plus 2 cosine 0 minus cosine 2. So consider like sine n is equals to uh something like sine n minus 1 plus n plus 1 over 2, right? So it's something like cosine n minus 1 plus n plus 1. So yeah, so actually uh this is cancelled out, this is cancelled out, this is then cancelled out, and then uh yeah, this is cosine n plus 1, cosine 4, cosine 5, cosine 4 is cancelled out. This is like this is like minus yeah, and this is cancelled out, right? But cosine n can cosine n cancel out? No, so something like this. So it's something like 1 over 2 uh 1 over sine 1, which is cosecant 1 times 1 plus cosine 1 minus cosine n minus cosine n plus 1. Yeah, something like this. Oh, yeah. And okay, so the answer is in the form of this one. So yeah, So let me check whether it's true. So this is 1 over sine 1 times 1 plus cosine 1 minus cosine n minus cosine n plus 1. Something like that. And yeah, so 1 plus cosine 1 minus cosine, this is like cosine 0. Cosine 0 minus cosine n, this equals to what about like combining this two and combining this two? Yeah. So it's like cosine 0 plus cosine 1 is 2 cosine 1 over 2 times cosine. Yeah, it's correct. Yes, it's correct. Of course. Yeah. So it's like because like 2 cosine 1 over 2. So cosine 1 will actually cancel off and in this it's double angle formula, right? Okay. It's a little bit because I am still kind of sickness. So I think my ability to doing math problems decreases a certain like at 4 points collinear and I will x coordinate. Okay. Yeah. So actually I picked this from the Trinity sample test, but I never dare to apply for Trinity, of course. Yeah. This is very I I apply for Curtin. Uh, yeah. And so for collinear on this, right, an average x coordinate should be k. So actually, I would like to consider the beta theorem. And so what about like, if they are collinear, I can express like another ax plus b. Ax plus b equals to this one. Yeah. And this equals so like, the first approach is beta theorem. Yeah, something like this. And so average x coordinate is so yeah, so like if for if there exists like yes, so firstly if there exists the real roots of four real roots, so let be x1 to x4, x1 to x4. So firstly I can express it into 2 x minus x1, x minus x2, x minus x3, x minus x4. And so if I want to focus on the average x coordinates, which is just like pick 3x and 1x. So yeah, so if I use the beta theorem, we can quickly obtain that so firstly so like negative x1 plus x2 plus x3 plus x4, this equals to 7 over 2, 7 over 2. Right. So the average x coordinate is negative 7 over 2. Yeah, this is a little bit so yeah, but I gave me a wrong hint on the second one, so I spent a lot of time. Yeah, because it's actually a wrong road, and uh, yeah. So this is what the video is lack of. So because like if I want to do it on the video, like in front of the screen, and I didn't prepare it, or like yeah. So because firstly, the good point, the advantage is like may uh this may be like more real, like the interview, right? But because this is like what I do for I myself, unlike like working with other people. Working with other people is like I do with you, help with each other. It's something like this, right? Uh, right. So I can prepare some hints, but in this case, first because I first I give I saw this sign the sign n this problem. It's a good problem, And um, and I saw the hint, which is using the 合唱话题, or like if I translate to English, which is sum of the trigonometric to sum of the trigonometric functions to the product of trigonometric functions, right? And I use sine alpha plus sine beta without hesitation, right? But because I think like this is sine 1 plus sine to n. But actually, I think like firstly, if I want to deal with that of trigonometric, if I want to deal with the trigonometric uh, problems, I'd like to like using a telescope, right? Because in this series use when tackling series, telescope is a very useful. Telescope is a very useful approach. Okay, and the third problem is very easy. So I'm wondering why Trinity picks it. Yeah. So, okay. Goodbye. See you next time.